Hey, what's going on everybody? My name is Caleb. In this video, we're going to talk about how to interface between Rust and C. So we're going to work with a C library and use that in our Rust code. This is pretty exciting stuff. This is going to expand your skills in Rust and C programming and just make you a better programmer being able to work with other software in your Rust programs. Now, I do have a video that's not necessarily prerequisite, but could be helpful, which is all about unsafe Rust code. I encourage you to check that video out if you want to get a better understanding of when you need to use unsafe, as that's going to come up a lot more when you're working with C code in Rust. Now, we're going to start with a very basic example just to show you that connection with working with built-in C functions, and then we'll go through another example working with custom code that has our own functions we've defined. The code for this lesson can be found at github.com, Caleb Curry, Rust-C, and then you can go into source to find both the C code created and the main Rust code as well. Now, I'm not going to code this C code from scratch in this video, so you'll want to get this file when we get to that point. For now, we'll just start with a new project, so we'll say cargo new, and we'll call this Rust-C. And then we'll open this in an editor. Great, so let's open up our main Rust file. So let's start by creating a variable, and this will be a floating point number, so 5.0. And say we wanted to use a C function such as the square root function. Let's make this mutable, and then we will reassign to it, so x is now going to be the square root of x, and then we will print that value. Well, currently, square root doesn't exist, and I'm sure there's something to do this inside of Rust. You could just say x dot square root, but for the sake of this video, we're going to use a C function to do this. So when we want to use C code, we'll go outside of main and use extern C and define the signatures for the functions we want to use. So this one is called square root, and this is going to be a function taking a value as an argument, so that will be called whatever you want. We can just call it x and say that this is of type f64, and this will return an f64 as well. So this should match the functionality of the function defined in C, basically taking a double, returning a double. And now this function exists, so the error we get is that it's unsafe and requires an unsafe function or block. So to do this, we'll just wrap this in unsafe. So we'll surround the calculation here, and that is the smallest section that we need to wrap in unsafe. After this point, we should be able to just print the value of x. Now this is making the assumption that you have done the checking to make sure this works correctly. So when you go outside of unsafe, you can confidently use x without worrying about something going wrong. So basically just do your due diligence to make sure the functions you're invoking are not going to cause issues that won't be caught by the compiler in Rust because it's a C function. So now we will run, so cargo run, and we get 2.23 some value. So you can see that the calculation actually worked. We didn't define the square root function, it just exists in default C, so we can just use it like this. So that's step one. You now know how to use C functions in your Rust code. But now I want to take a big step up in difficulty and actually work with our own C code. So to do this, we're going to do a few things. First, I'm going to put some C code inside of our source file. You can put it wherever you want, but I'm going to grab this from the repo and we'll just copy the code. So you don't have to clone the repo if you don't want or anything, just copy. And then we'll go create a linked list.c. So in source, linked list.c. This is going to be our C code, which by the way, I'm doing this on Mac. As we go to compile this, it might be different on other operating systems, so just keep that in mind. I'm not going to go through this for every operating system. If you do end up doing this on Windows and you find anything interesting, definitely let me know in the comments so other people can see that. So we basically have the header file, which shows the signatures for all of the functions, and then the implementations in the .c file. Now this is just a basic implementation of a linked list. It's probably not flawless, but it's pretty good. It covers some of the basics like creating a linked list with this generate linked list function, which will return a linked list pointer. So we're going to learn how to work with custom types as well. This is actually the first function I want to use so we can generate our linked list and start working with it. So let's go back to our Rust code and we can replace in this extern section a function generate linked list, which will match the name exactly to right here. And this is going to return a pointer to a linked list and it doesn't have any parameters. So the return type here is going to be a pointer and we'll make it mutable to a linked list type, which we're going to define. Now, when you don't need the internal structure of a type in Rust, what you could do is you can just define it as an enum. So we'll say pub enum linked list and then just keep it empty. So now this type exists, and instead of just working with this variable here, we will replace this with a list variable, and then we will give this a value down here. So list is going to come from generate linked list, and then we should be able to work with that list, but we're not quite there yet. Let's just comment this out or remove it, and we will build up to the point of working with the linked list structure. But for now, just hover over a linked list, confirm its type. It's a mutable pointer to linked list. And you might just think, all right, we're good. So we'll say cargo run, but this isn't going to work right away. Undefined symbol, generate linked list. So we need to basically say, hey, where the heck is this coming from? Since it's not built in C, we need to go a little bit extra to include this in our Rust program. So to do this, we will go into the root of our project and create a build.rs. And here we can put in commands to statically attach our C program to our Rust program. So this is going to be a static library. And what that means is the library is included at compile time and is part of the program, and it's not dynamically loaded at runtime. The code we're going to use for this will look like this. I'm just going to paste it in here and you can write it out if you wish. Or you can grab it from the repo here. And let's take a look at what this is doing. So this is linking a library called linked list. And this is going to end up being located in a folder called lib with a file called lib linked list.a, which by convention, a static library will have lib and end in a .a. So we need to create that file because currently we just have the C code in the header file. It's not actually compiled. So let's go to the terminal and type in a command to compile this into that library file. So we'll first create the object file, which is going to be the compiled C. So we'll say gcc-c with the output just being source. I'm just going to keep it in source. Feel free to put it wherever you wish. Linked list.o, and this is going to come from linked list.c. So that's going to compile the C file. Also, the linked list file is in source as well, so we'll need source on both of those. And that will put this object file inside of source. Now this is generally considered an artifact, not a source file, so you might want to put it in the root of your directory or wherever you want to put it. But because of that, I have it in the .getignore because it's not something that needs to go into the repository because you can just generate it from compiling the C code. Then we're going to use AR for archive tool and then RCS. So I'm not an expert with this command, but I think what this will do is it will replace any file named this inside a library and it will create it if it doesn't exist. And then S is some kind of indexing, which I think is used for speeding up the linking of the libraries or something. I don't exactly know. All I know is we need to use this command to generate the library file. So the destination for this is going to be lib and then lib linked list.a. And the source for this is going to be source linked list.o. Hit enter and we'll see that the lib linked list.a was generated. And now we should be able to say cargo run and nothing shows up, but that's great. We compiled and we ran. We just didn't do anything because all we did was create the linked list. But now we know that our files are connected and we can start using some of these other functions. Now generally you would say cargo build to work with this build file, but that is automatically done with cargo run. So I don't think it's a separate requirement. Great, so at this point you have a pretty decent understanding of working with your C library. Now we're just going to go through some examples of working with different functions so you understand how to work with the C code. Specifically, we're going to learn how to push data into our linked list. That's going to take an argument of the list itself as well as what the data we want to add is going to be. Then we'll talk about printing the linked list. That's just going to take an argument of the linked list, but that will show us that we can then see that data inside of our Rust code and it'll be outputted to the console. And then we will free the list, which is something you need to do with memory in C. We're also going to learn how to search and get data from this linked list, which is going to actually return a position. So we haven't looked at the details of the C code, but I custom created this linked list to work with positions. So if you want to insert data, you're going to give it an X and a Y, and that's ultimately going to create a node. And a node structure is actually going to contain a position, which has an X and a Y. So now we're actually going to have to work with a custom type that has those fields. So it's not just going to be an empty enum. So I know you might not have like a full understanding of the linked list structure. That's fine. I don't think you have to understand this code. I'll teach you everything you need to know as we go. So I'm actually just going to look at the header file because we don't need to worry about how it's implemented. So we really just need the header file and main. And we're going to use one of these push functions to add data to our linked list. I'll just go with pushback and I'll just copy this just to reference it easier. And up here, I'm going to paste. Come on. There we go. And now we could just create this function. So it's a void function, so you don't have to worry about the return. We'll say push back. And then we'll only have to worry about the parameters. So the first one is a linked list. We already saw how to create that type here, so we can just copy this for the type, and we'll just call it list. So it'll look like this. And then int x, int y, that will be x I32. And y I32. So that's how we would create the signature to match the C equivalent. And I will remove that. Now we can invoke push back, passing in our list, and then some data such as 5 and 10. So this would be the XY coordinates for the position we're adding to our list. And I just need to match the capitalization here. So that should, in theory, add data to the list. We can't actually see it yet, so that's why I want to print the data. But let's just add this in a few more times. So we'll do 5, 10. Just some random data. Put whatever you want. Okay, cool. So we added in the data. Now let's learn how to print the data. So let's head back to the header file and search through here, print list. So this is the function we want. I'll bring it over here, comment, paste it, and we will try to match this signature. So to do that, we will say fn print list, no return, so it's void, so we don't have to worry about the return, and then just the parameter as a linked list. So that's easy. We'll just copy this and paste. And now we should be able to come down into main and print the list, passing in our list as an argument. And there you go. That's how you work with the linked list. So we can now say cargo run, and we should see that list printed out. That's pretty awesome. We basically brought in a data structure and all of the implementation around the data structure and just have a few lines of code in Rust, and it just works. It's pretty exciting. It took me a while to kind of like wire all this up, but once you got it going, it's pretty easy just to add functions in here that you need. At the end, we will free list. So that's going to be pretty similar to the print list here. I actually don't even think I need to paste this, but I will just double check. So it's just going to take a linked list. So free list, passing in a list. And then once we're done working with the list, we can just invoke free list. Cool. So that is the basics. Now I want to go through a more advanced one, which we could, for example, search the list, which is going to return a position pointer. This is a bit more complicated of a structure, so let's bring that one in. I'll paste that and comment it out. So let's craft this. This is going to be called search list, and the return is going to be a pointer to position, which currently doesn't exist. So we'll make that in a second, but let's just copy this parameter list real quick, which should match pushback, it looks. So the list, X and Y. So I'll copy this and paste that here. Now let's craft a position. So it's not going to be an enum because we need to worry about the properties of a position, which are X and Y. or you could say the fields of a position. And we will do that by saying pub struct position, and this is going to have an x and a y. So x is I32, and then y is I32. And don't use a semicolon like me, use a comma, and you should be good to go. Now, this isn't going to fix it 100%. And you can see it says block uses type position, which is not FFI safe. Consider adding a, whatever this is, attribute to the struct. So an attribute will describe something about the structure we're building, and I believe this is for representation. And what this is saying is that the way this is stored in memory, we want it to match the way it would be done in C. That way the order and size of all of these fields are in line with the way it would be done in C, so that we have matching object structure. Now we have that type and we can start working with it. So let's test it out. We'll come down here, and before we free that list, we will search for a node. So we'll say search list, and this will take the list and then an x and a y. We'll just pass in one we know exists here, and then we can create a variable to store this. So this will be called position POS, and let's try printing this data. So print line, and in here we will print the x and the y. So outside of here we'll say POS dot, and we will actually need to dereference this, so it'll look like this. And now we should get x, and then same thing for y. So dereference the position and access y. Make sure you put those parentheses in there for operator precedence. Otherwise, the dot x or dot y tries to happen first, and then you're trying to dereference an integer. So this is the way it should look, and we run this, and we get 1640. So that looks great. I meant to put a comma there too. All right, cool. So we have the basics, but another challenge with this function search list is what if we don't find that data? And that's where unsafe is really important, because we're dereferencing, and it's basically saying, hey, in theory, we could dereference a null pointer. So just because we are within unsafe doesn't mean we should do that. It just means we need to be extra careful. And by that, we should probably check to make sure it's not null before we try to dereference. Because if we put in a value in here that doesn't exist, we run and we get a seg fault. Bad. So let's try to fix this. We can run this line fine. We can search the list, because the search list function will return a null pointer if it doesn't exist. Then all we have to do is check down here. So we'll surround this whole thing in an if, like this, and then the condition for the if, not POS dot is null. Then it will print that data. Otherwise, you could say something else, such as the data is not found. Now we run it and we get data is not found. Cool. So we at least improved the code here, and we're not going to have any runtime issues. This works, and feel free to do it this way, but I wanted to show you one other option, which is actually to convert it to a smart pointer, and then you can work with it in a more Rust-like way instead of checking if it's null whenever you want to access it. To do that, I'll just create another variable here. So we'll call this POS pointer, and what you can use is called non-null. So non-null, new, will take a pointer and give us an option. So if we hover over this, it's going to take a pointer and return an option, meaning optional data. That's kind of more basic Rust you should probably be familiar with, but definitely check out my beginner Rust video if you're not familiar. So in here we could take POS, and that will convert this to an option. So maybe that's a better name. I don't know what to name it, guys. Okay, just name it something. And then we can print this with a match, making sure the data is not null. So for this we could say if let, and then say we do have some data, and this is going to come from POS option. Then we can print that data. So I am going to copy this, paste. Syntax will be a little bit different here. So we'll say data dot as ref dot, and then the field. So X, and we'll do the same thing for Y. So copy this, paste dot Y. And then the else can go here as well. And then we'll take this line paste. So this is the other way we could do it in a more Rust-like way. And then cargo run, and we get data is not found. If we change it to something we know is there, cargo run, and we get the data. So the end result is the same, but now you can use the matching and you don't have to worry about dereferencing a null pointer. Last one I wanted to cover is this one here, which is to get data passing in an index, and this returns a position, not a pointer. So it's slightly different. So I just wanted to go through this example real quick. Let's bring this function in. So I will bring that in and recreate it here. So get, this is going to take a list and then an int index. So first the list, and then index, which will be an I32. Cool, so we got the function here. Now we could try using it. So I'm going to go down here and invoke get, passing in our list. And let's try to grab index 3. So that'd be 0, 1, 2, 3. So this one right here. This is just going to give us a position. So when we say let data be get, hover over this, and we should see, I think I forgot to put the return type. So let's go back up. And this returns a position. Now, when we hover over data, we should see that it's of type position. This is pretty easy to work with. So we'll say print line, passing in, just as an example here, data dot x. You can just access it directly. You don't need to dereference. Cargo run, and we get the value 40, which is this value right here. So that works as expected. Now, you still got to be careful, right? Because you could go outside of the bounds, and then, you're going to crash. So before you try to get data, you probably want to check the bounds to make sure that the value you're giving here is not larger than the size of the list, which I think there's functions to get the size. You can look into that if you wish, or you could just, keep track of that inside of the Rust file as well, based on how much data you've inserted. That's all I have for working with C inside of Rust. As a reminder, all of this code is up in the repo. It might not be exactly the same because I wrote it ahead of time, but it's going to be pretty close and will show you some of the same structures. Let me know what other things you want to know how to do in Rust or just programming in general. Would really appreciate the feedback, the comments, and stay tuned for upcoming episodes. Please be sure to subscribe and select notifications so you get notified when I create new videos. Thank you so much for watching, and I'll see you in the next one.